All right, our goal for section 5.2 is to develop some models for multiplication and division of integers. I'm going to let you read this example and think about what the answer might be yourself. We're going to talk about some models here. All right, so we're going to start with the pattern model. So we can find 3 times negative 2 using repeated addition. So remember, our repeated addition model tells us that the first number is going to tell us how many times I need to repeatedly add the second number. So 3 times negative 2 means to add negative 2 3 times, and that gives us negative 6. Now, if I wanted to find negative 2 times 3, I'm just going to use the commutative property to rewrite this as 3 times negative 2, and then I can use the repeated addition that I used above to get negative 6. Now to find negative 3 times negative 2, I'm going to use a pattern. So I've got 3 times negative 2 is negative 6. 2 times negative 2, again, I could use repeated addition to find that's negative 2. 2 times negative 2 is negative 4. 1 times negative 2 is negative 2. 0 times negative 2 is 0. And now I see a pattern, right? My numbers are increasing by 2 at every step. So negative 1 times negative 2 must be 2. Negative 2 times negative 2 is 4. And negative 3 times negative 2 is 6. We can also model multiplication using a chip model. So let's model, we're going to look at the same product, 3 times negative 2. So the first number I'm going to interpret as put in, because it's positive, put in 3 groups of, and the second number is going to tell me what I need those groups to look like. So 3 groups of 2 red chips, because I'm looking at negative 2. So I'm going to put 3 groups of 2 red chips into my circle. And if I count those, there are 6 red chips. So 3 times negative 2 equals negative 6. Now what if that first number had been a negative? So if the first number in your product is negative, we're going to read that as remove. Okay, so remove 3 groups of 2 red chips. So I'm going to start with a circle that has 0 in it. Now I need to be able to take out 3 groups of 2 red chips. And we can represent 0 with any number of pairs of red and yellow chips. So what I'm going to do is put in 6 pairs of red and yellow chips. In particular, that's 3 groups of 2 red and yellow chips. Okay, so that's still 0. And now I'm going to remove 3 groups of 2 red chips. So I'm going to take out all of those red chips, and I'm left with 6 positive chips. So negative 3 times negative 2 equals 6. Again, I want to be able to see this interpretation in your work that you turn in, and I want to see the progression of these steps, all right? We can also model multiplication using the number line. So again, just like with addition and subtraction, we're always going to start at 0 facing to the right. If a number is positive, we walk forward. If a number is negative, we walk backwards. So let's look at what's happening here. Here I want to model the product 2 times negative 3. And so what that means is that I'm going to move 2 groups of negative 3. Now remember, negative 3 means moving backwards. So I've got a little cat here, and the cat is moving backwards negative 3 units twice. And that takes me to negative 6. So 2 times negative 3 equals negative 6. Well, what if we had two negatives? So now I have negative 2 times negative 3. And we're going to interpret this as the opposite of what we just did above. So the opposite of two groups of negative 3. So what we're going to do is we're going to do our two groups of negative 3 just like we did above, and you can see my cat's going 3 units backwards twice, and that puts them at negative 6, but I want the opposite of negative 6, so I'm going to move to the number that is the same number of units away from 0 to the right, which is 6. So the opposite of negative 6 is 6, and that's going to be my answer here. So negative 2 times negative 3 is positive 6.